Right, so I want to go over one more time where I got those values for epsilon and L and C. So I rewrote the definition of the limit right here. And so in the definition, it says 0 is less than the absolute value of x minus c. So the 2 is in the place of where the c is. And then that's less than delta. That's what we're looking for. And then the rest of the statement, absolute value of f of x minus L. So the 3 is in the position where the L is, and that's less than 0.2. So the 0.2 is in the position where the epsilon is. If you go back and look at your definition of the limit. All right, so now I want you to focus on part B, the table, and it might help you to also look at the graph. But normally in the table, I have given you numbers before the x that we're interested in and numbers after the x that we're interested in. And we've used those to determine the limit. For this illustration, we're going backwards. So I'm telling you the x that we're interested in, and that's the 2, the c that equals 2. And I'm going ahead and telling you the limit. I know that the limit that I want to get is 3. And so my question is, how precise do these two x values have to be in order to get my f of x, my y values, to be within 2/10, and that's what this epsilon is up here, to be within 2/10 of my limit, which is 3. So to be within 2/10, that means that I have to get above it at 3.2, or I have to get below 3 by 2/10, and that would be at 2.8. All right, so if I'm going to want to get those y values, then I ought to be able to take my expression, or my equation, f of x equals x squared minus 1, and set that equal to the y value that I want to get. So the first one I'm going to do is x squared minus 1 equals 2.8. And so I'll add 1 to both sides. So x squared would equal 3.8. And then you can use a calculator and do the square root. And you only need the positive value because that's what we're dealing with right here. And so x is approximately 1.95. All right, so I know that in order to get a value of 2.8, then my x has to be 1.95. All right, and then I want to find that other side, or the other one, so I'll do x squared minus 1 equals 3.2. And so I'll add 1 to both sides. X squared would equal 4.2. Square root, use the positive root, and x is approximately 2.05. So I know that if I get that close to my x that I'm interested in, then I will have a y value that's within my acceptable margin of error. So now I have to look and see what is my margin of error for the x. And that is going to be the difference, or the absolute value of the difference between 2 and the two values that I got for x. And so that's going to equal 0.05. And I can subtract both of them, 2 minus 1.95 and 2 minus 2.05. And both of those equal 0.05. So that means the delta that I was looking for is this value. So if I'm within 5/100ths of the 2, then I'm guaranteed